Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. So let's see this problem. We are given two numbers x and y. Our task is to consider binary representation of both the numbers and copy all the set bits in a range from number y to number x. So it is a little bit tricky to understand. So let's understand this problem with some examples. Let's first see first example. Here x is equal to 13, binary representation of 13 is 1101, y is equal to 7 and binary representation of 7 is 0111. The range is given as 1 to 3. It means we have to consider binary representation of number 7 and we have to copy all the set bits from first position to third position in x. Here you can see that from first to 3 we have 3 set bits. Okay, so we have to copy all the 3 set bits in number x, and in number x at first position bit is already set, in second position bit is not set, so we are going to copy this bit from here over here. Okay, and third bit is also set by default. So after copying all the bits, set bits from number y to x, our number becomes 15, and the binary representation of number 15 is 1111. So far so clear. So let's see next example. Here x is equal to 16, binary representation of 16 is 1 0 0 0 0, y is 2, binary representation of number 2 is 0 0 0 1 0. The range is given as 2 to 4. So we have to copy all the set bits from position 2 to 4 from number y to x. And you can see it clearly that only one bit is set in range 2 to 4. So we just have to copy this bit to this position. So we just have to copy this bit at this position of number x. After copying all the set bits, our binary representation looks like this. And this is equivalent to 18 in decimal. So now you have a good understanding of this problem. So let's pause the video and think about an algorithm to solve this problem. Okay, I hope you would have written at least basic program to solve this problem. So let's first see the brute force approach to solve this problem. And the idea of brute force approach is pretty simple. What we do, we basically traverse number y in a given range. If the range is given as 2 to 3 or 2 to 4, we just have to traverse binary representation of number y from 2 to 4. And in each iteration we check if bit is set or not. And if the bit is set, we are going to set exactly same bit in number x. So here we are using two tricks. First is to check the bit is set, and next to set the bit. And how we check if bit is set or not? Let's say number is 0 0 1 0. And if I want to check if second bit is set or not, we simply do bitwise AND with number whose second bit is set. Right? And if we get number that is not equal to 0, it means bit is set. Okay? And how we set any bit in a number? Let's say number is 0 0 1 0, and if I want to set this bit, then what we have to do? We have to do bitwise OR with a number whose third bit is set. After doing bitwise OR, we get this bit as set. So these two operators we are using here. So this is the simple idea. So let's see the implementation of this approach. So here we have a function. This function is taking x, y, ln r. ln r are the ranges. Okay. Inside this function we are running a loop from l-1 to r. It means if the range is 2 to 4, we are running loop from 1 to 3. And why it is like that? Because binary representation is based on 0 index. Or we can say the bitwise operator works like this only. Okay. Inside this loop, we are checking if the bit is set or not. If bit is set, we are simply including that bit in number x. This is exactly same as this two steps. We are checking if bit is set or not, and then we are including that bit in number x. So let's quickly try run this code and see how it works. So if x equal to 16 and y equal to 2, r is given as 2 to 4. Means we have to check in a range of 2 to 4. The binary representation of number 16 is 1 0 0 0 0 and 2 is 0 0 0 1 0. So we are going to run a loop from 1 to 3. In first iteration, we check if first bit of a number is set or not. And this time we can see that first bit of number 2 is set. So we are going to include this bit in number x. So after including this bit, our number becomes 10010. Right? In next iteration, when I becomes 2, we see the second we are going to check if third bit is set or not. And this time third bit is not set. So we are not doing anything here. In next iteration, that is the last iteration, we check if fourth bit is set or not. And fourth bit is also not set. So we are not doing anything here. And after 3 iterations, our loop gets terminated and we get output as 18. And the binary representation of number 18 is 10010. So you can clearly see that in a range of 2 to 4, we have copied all the set bits from number y to number x. So we can see that from 2 to 4, we have only one set bit. So we have set this bit in number x also. Okay, so far so clear. Talking about the time complexity of this function, how many times loop is running? So here you can see that clearly the loop is running r minus l plus 1 times. It means 4 minus 2 plus 1 3 times. And you can see that 3 times we are running loop. So in worst case, we can say that this function is going to take big of r time to solve this problem, where r is equal to the greater number in range, that is 4. In this case, that is 4. So in worst case, it is going to run 4 times. So what about space complexity? As you can see that we are not using any extra space other than all the variables. So we can say that the space complexity of this function is going to be theta of 1. And it's a constant space. So it means brute force approach takes big of r time to solve this problem and constant space. Okay, great. So this is all about brute force approach. But as you can see that we are doing a lot of work here. We are running a loop 4 times to just solve this problem. So can we do it better? Do you have any idea how to solve this problem in a constant time? What about bitwise operators? We have so many bitwise operators. If you think about all the bitwise operators, then you might get some idea that can solve this problem in a constant time. So just think about all the bitwise operators and how this bitwise operator can help us in solving this problem. Okay, moving on to efficient approach. So let's now discuss the idea of solving this problem efficiently. So let's say we have two numbers y and x, and the binary representation of this number is 0011 0011, and the binary representation of number x is 00000111, and the range is given as 5 to 6. It means we have to copy all the set bits in range 5 to 6 from y to x. So when we copy both the bits from y to x, our x becomes 00110111. So here you might be thinking that, okay, it's pretty simple. We have to just find a number whose bits are set from 5 to 6 and all other bits are unset, and we have to simply perform our operation with x and we get this number. This is what I have done here, 00110000. This is the number and we call it bit mask. So we need this bit mask and just have to perform bitwise OR with x number x. We get both the bits are set. So if you are thinking this solution, then think about it once more, because you are making one mistake here. In this number, you are getting 2 ones, but it might be possible that you get a number where you get bits like 101 in the range of 5 to 7. And if we apply the same idea here, just finding a number whose 3 bits are set and then performing bitwise OR with number x, you get a wrong result. Here you are expected to get 101, but if you apply the same idea, you get 111, and that is a wrong answer. So to avoid this problem, we have to perform one extra step, and that is we have to perform bitwise AND with number y. Why? Let's say this is a number and from 5 to 7 we have 3 bits, and out of 3 bits 1 bit is unset. So we do not want to count this bit, right? So that's why we have to perform bitwise AND of number y with our bit mask. After performing bitwise AND with After performing bitwise AND with our mask, we get a number 01010000, and this is the correct number, and this is the number we are looking for, because in this number only 2 bits that are set exist, all other bits are unset. Okay, so now if we consider these numbers, we need 2 things. First thing is we need a number whose 2 bits are set, and that bit exists in a range of 5 to 6. So let's keep this range aside as of now and only focusing on the number whose 2 bits are set. Okay, so how we find that how many bits we need to be set? We simply do 6 minus 5 plus 1, that is equal to 2. Means from range 5 to 6, total number of bits are going to be 2. So we need a number whose 2 bits are set like this, 00000011. So think about it, how we get this number. So if you have been watching this playlist from the first video, you must have known about Brian Cunningham's algorithm, and he made an interesting observation. And what the observation is, if you have a number 2 and if you find power of 2 with that number, you get a number, and the number and the binary representation of that number is 0100. Means here we want 2 bits to be set. So when we do power of 2 with that number, we get a number, and if we subtract 1 from this number, we get a number where this bit gets unset and all the numbers before this bit are inverted, right? So we get 0011. So this is what we are looking for. So we got our number where 2 bits are set. And how we got it? Using the Brian Cunningham's observation. So if we find power of 2 as with respect to this number, we get a number, and we simply have to subtract 1 from it, we get our number. So let's say we need a number whose 4 bits are set. So what we have to do? We have to find power of 2 with 4. We get a number. So we get a number, and if we subtract 1 from it, this bit gets unset and all the previous bits gets inverted. So this is how we get a number whose 4 bits are set. So one thing is done. So we now have a number whose 2 bits are set. Now think about a solution where we have to find number whose 2 bits are set in a range of 5 to 6. So how we do it? So if you look at this number, we have 2 bits are set. Now we just have to shift this 2 bit at the 5th position. Okay. So how we shift these bits to 5th position? We know that we can use left shift operator or right shift operator. If you want to move bit left side, we use left shift operator. If you want to move bits right side, we use right shift operator. Here also we are going to use left shift operator. So how many position we have to shift? If bit is at the 0th, if bit is at the first position, how many position we have to shift? 1, 2, 3, 4. 4 position we have to shift. So if we shift this number 4 position towards left, all these 4 bits gets discarded and these bits shifted towards left by 4 position. Okay. And how we get 4? We just have to subtract 1 from L. L is what? 5 and R is what? 6. So L minus 1, 5 minus 1 is equal to 4. Correct? So you can see that we finally got our number whose 2 bits are set in a range from 5 to 6, and we call this number bit mask. So this is our bit mask, and using this mask we are going to get a number where we get only set bits in a range of 5 to 6. So after getting bit mask, we have to perform one more extra step, that is doing bitwise AND with number y. And I explained the reason. If you get a number like 101, and when you do bitwise AND with 111, you get only 1 and 1. Okay? Because we only need these 2 set bits. We do not want to consider this bit. This is 0. So we need 0 also here. So that is why we are performing bitwise AND with y. And after performing bitwise AND with y, we get our final mask. And now we simply have to do one thing. We have to do bitwise OR with this mask. So when we do bitwise OR with this mask of both the number, we get 00110111. Now you can see that we have successfully copied both the bits from 5 to 6 in X. and the binary representation of number x is 0 0 1 1 0 1 1 1. So far so clear. So this is the entire process we have to follow to copy bits from number in a range to another number. So let's see the implementation of this efficient approach. So here we have a function as same as before. Inside this function we are performing all the constant operation. In first step we are finding mask, and then we are shifting mask towards left by some position, and then we are doing bitwise AND of mask with y, and then we are performing bitwise OR with x. So these are the three steps we are doing in this function. So in case of 16, binary representation of number 16 is 1 0 0 0 0 and y is equal to 2. Binary representation of number y is 0 0 0 1 0 and range is given as 2 to 4. So if you look at this binary representation from 2 to 4, only one bit is set, and we have to copy this bit in 16. So first we are going to calculate mask. To calculate mask we have to find power, and to find power we simply have to do 4 minus 2 plus 1 is equal to 3. So 2 to the power 3 is equal to 0 1 0 0 0, and after subtracting 1 from it we get 0 0 1 1 1. So we finally got our number whose 3 bits are set. Now and the next task is to shift these 3 bits towards left by 1 position, because here L is equal to 2, L minus 1, 2 minus 1 is equal to 1. So we get our final mask. Okay. Then we are doing bitwise AND with M to get all the set bits, and then we are simply performing bitwise OR with number x to copy all the set bits from mask to x, and this is what we get at the last, and this is our final answer. And the decimal representation of this binary representation is 18. So as you can see that we have successfully copied all the set bits in range 2 to 4 in number x, and then it becomes 18, because this bit represents 2 to the power 4, that is equal to 16, and this bit represents 2 to the power 1. So 16 plus 2 is equal to 18. So far so clear. Talking about the time complexity, as we are doing all the constant operation, that's why the time complexity comes out to be theta of 1. Similarly, we are not using any auxiliary extra space to solve this problem. That's why the space complexity also comes out to be theta of 1. Clear? Okay. Before we end this video, let's have a quick recap of what we have done so far. So we are given a problem. In this problem, we are given two numbers x and y and range. And our task is to copy all the set bits in a range of number y to number x. To solve this problem, we saw the brute force approach, and that approach took big of r time to solve this problem, where r is the greater number in the range. After brute force approach, we saw the efficient approach to solve this problem. In this efficient approach, we have extensively used bitwise operator. This approach took theta of 1 time to solve this problem. So this is it for this video. Thanks for watching. See you in the next video.